Welcome to our Centera product video. Today I would like to introduce you to the RTVS Transformer Fan Speed Controller. You will probably all recognize the Transformer Fan Speed Controller by the rotary switch with 5 positions. With that rotary knob you normally manually adjust your fan speed based on intuition. Thanks to the built-in transformer, this is done with a perfect sinus-shaped signal as it comes from the mains. It is only the amplitude of the signal that you're going to change. So instead of 230 volts, the same beautiful sine wave shape comes out of the unit with an amplitude of 80, 110, 170 volts and so on. And this depends on the position of the rotary switch. The principle of transformer fan speed control is known to be very good for your motor. Your motor is therefore not very sensitive to wear and tear, unlike some other ways to regulate fan speed. The RTVS also works according to the principle of transformer fan speed control, but he is not equipped with a rotary knob. You need to operate it via a digital signal, Modbus RTU. That actually makes the device extremely suitable for demand-based solutions. This means that the position of the transformer fan speed controller will depend on, for example, a measured value that comes from a sensor. Centera sensors that can measure temperature, relative humidity, CO2, NO2, CO, TVOCs, that's indoor air quality, mostly exist in a version that has an RJ45 connector on board, power over Modbus connection. In concrete terms, this means that you cannot directly control a fan with this sensor, but that you need to connect them to the transformer controller with a regular network cable, RJ45 on both sides. In this way, the sensor automatically receives its power from the fan speed controller, and there's also data communication between both devices. You could say, the higher the CO2, for example, the higher the position of the fan speed. In this way, the polluted air can be extracted and fresh air can enter the building, for example, in a natural, unforced way. For demonstration purposes, it is of course difficult to simulate a nicely moving CO2 curve right now. Therefore, we should be able to make additional CO2, which is not the case. Well, Centera nowadays also has potentiometers equipped with a Modbus output. That actually means that by turning the knob, I can simulate the output value of a sensor. We're going to do this in a moment in this setup. This potentiometer, which is equipped with Modbus RTU, can of course also work on its own as control for the RTVS, Transformer Fan Speed Controller. The connected device doesn't necessarily need to be a sensor. The advantage of this potentiometer compared to traditional potentiometers with 0 to 10 volt analog output is that you can place it much further from the RTVS. The Modbus signal can be sent over a distance of 1000 meters. And in case the Modbus signal's amplitude weakens too much anyway, it can easily be boosted up with a repeater. So you can put this controller very far away from the fan speed controller itself. And finally, you can also equip the controller with a Centera gateway. Again, using a standard network cable. You can connect this device to your Wi-Fi network. In this way, you make the controller accessible through the internet. In addition to the fact that it is a transformer fan speed controller, a technology that has already proven several decennia long to be very good for your motor, this device has a lot of extra options that are all located into the Modbus registers. At the end of the video, I'm going to take you inside the unit's processor to see which settings are all possible. When you open the device, pay attention to the flat cable. At the bottom of the PCB, you will see two RJ45 connectors. If you want to work with a demand-based control or a Modbus potentiometer, you will connect this to the left RJ45 connector. If your sensor is a multifunction sensor that records several measured values, then you need to determine in the Modbus registers whether the device should take CO2, relative humidity, temperature or any other measured value into account. On the right RG45, you can connect a Centera gateway or a building management system. If you connect a Centera gateway, you can manage the device through the internet. On the left side of the unit, you'll notice these terminal blocks. At the very bottom, we'll see the TK connections. Just above it, we see the connections to the motor, and at the top is a 230 volt from the mains. And finally, there are the two middle connections where we find a 230 volt unregulated output. On a traditional transformer fan speed controller, 230 volts will be applied to this unregulated output as soon as the rotary knob is in positions 1 to 5 and not at the 0 position. Since this controller has intelligence on board through its Modbus registers, you have many more options. For example, you can reverse it so that the 230 volts is applied to the unregulated output when the regulator is in the 0 position and not if he provides power to his engine, or when a TK alarm comes in so that you can, for example, operate a warning light or a buzzer. There are several more options for controlling the unregulated output. I am thinking of overload, overcurrent, overtemperature inside the unit, and so on. All things that the logic will perceive and with which you can control this unregulated output. I repeat briefly the two operating modes of the device. First, it can operate in a manual mode where you can select the speed between 1, 2, 3, 4, 5 in the Modbus registers via a computer or via a building management system. Or it can be operated in automatic mode listening to the sensor or potentiometer on its slave input. Also keep in mind that certainly in the case of demand control, this is with the sensor connected, it is very important that the unit works with a certain delay. If not, any fluctuation in the sensor would immediately result in another step. The RTVS could then start tripping between two speeds, for example 3 to 4, 3 to 4 and so on, which of course does not benefit the internal electronics, neither your motor. That is why there is a certain delay that again via Modbus you can set from 5 seconds to 10 minutes. I'm now going to demonstrate how it works. I'm going to increase the speed with the potentiometer and you will see that the device switches with some delay from speeds 1 to 3 to 2, to 3 and to 4. You will also be able to determine this by the means of the LEDs on the device. I'm going now to turn the potentiometer all the way to the far right position in one movement. You will see that the speed increases with an interval of 5 seconds, which is actually a bit too fast. In practice, the speed should upshift more slowly, but anyway, for the demonstration purposes, we set it to 5 seconds. You have noticed that when switching off to the 0 position, the unit stops immediately. With this Modbus to USB converter, we make the transition of the Modbus signal from the Centera devices to the USB port of your computer. Again, we make use of a standard network cable to connect the converter to go to the unit. In this case to the RTVS, but of course the same applies to all other Centera devices that are equipped with Modbus. I plug the connector into the master socket. Via the 3S Modbus software, now going to look in the registers of the device. We start the 3S Modbus 3SM Center software suite. If you are connected to the internet, it will check if there is an update available. Then we start 3S Modbus. 3SM boot is used to update the firmware of your device. The system will automatically scan for all available IDs and will immediately find the device on ID 1. This is the factory setting of all our devices. We have found our RTVS, so we can stop the scanning. If we click on the icon, we enter the screen of the Modbus registers, and on the one hand we see input registers, where we can read everything that is sent to the output as well as the status fields. And on the other hand, we see the holding registers in which we can change parameters by clicking on these icons. We see here that the current output step of the RTVS is 0, and this is correct because the desired step is also set to 0. If you would like to change this, we will start by putting the unit in the manual status via this parameter. After which we choose, for example, 3 as the output step. As soon as I activate this, you will see that the desired output step is step 3 and that this step is going to increase with an interval of 5 seconds as set in Modbus register 4013. 3 is the desired step. The device starts up and is currently in step 1. 5 seconds later it goes to 2 and finally to 3. I'm now going to switch off the device. In addition to the manual mode, we also have the automatic forward and the automatic reverse mode. In these modes, the unit will work demand based. Therefore, we have to connect a potentiometer or a sensor. We have to indicate in Modbus register 4018 which value the device has to take into account. With the potentiometer it is obvious that this is set on potentiometer, but with a multifunction sensor you also have to choose which of these values the device should take into account. I'm going to keep it to this as far as it concerns the Modbus registers. It is pretty much explains itself. However, I will show you what the relay should respond to. Via Modbus register 4019, you can choose whether the 230 volt non-regulated relay output will respond as soon as an alarm occurs, or that you're going to switch this output manually via Modbus register 4015, or that the 230 volt is applied to the output as soon as the unit switches to positions 1, 2, 3, 4, 5, or even the other way around, 230 volt is applied to the unregulated output when the unit is at 0 position. We will take a look at the different alarms that can occur as well as the meaning of all those other Modbus registers in the Modbus register map. The Modbus register map for each Centera Modbus product can be found on the Centera website. You choose products, enter the name of the device here, then you just choose a device. The amperage does not matter for these Modbus register maps. And in addition to the datasheet and the mounting instructions, you'll find the Modbus register map, where you can get an explanation of all input registers with all possible statuses and output values, and of all holding registers and how to set them. And if we return for a moment to the issue of the alarm status that we just discussed, you will see that the value 0 indicates that the device is operational, but that there are 9 different reasons why an alarm can occur. For example, if a TK, thermal motor issue, is detected, or if there is an overload from the motor, or overcurrent, or overheating the unit itself, and so on. That's it for this video about the RTVS transformer controller with Modbus. It is available in 5 models ranging from 1.5 to 7.5 amps. Below the video you will find the links to the datasheets of the RTVS, to the datasheet of the used potentiometer, and to the USB converter. I look forward to seeing you in another video.